I'm going to give you one more example, and this example is different from that one. Here we are given the roots of the characteristic equation and we want to find the general solution. We write the, so we have to take care of these basic ideas. When the roots are repeated, we multiply by x. So that's the idea we're having. When they are not repeated, then simple we get the solution, because they must be linearly independent. To make it linearly independent, we multiply by x. So first we make the groups of these roots and then we write our solution. Let us see here. So when we write the solution, we say here this is my 0, 0. Then I take 0, 0 together. I having here three zeros, 0, 0 and 0. This 0 also I shift to this one. Then I have 1. I have here two ones, 1, 1, and then here is minus 1. And then we have the complex root 3 plus minus 2i and 3 plus minus 2i. So now I am in position to write my general solution. My y is equal to, when we see e to power 0 is 1. So get here c1, then c2, e to power 0 is 1, we multiply here by x because the root is repeating. Then c3, again root is repeated, multiply by x, become here c3 x squared. So this is for the root 0, 0, 0, c1 plus c2x because root is repeated, and e to power 0 we are not writing because e to power 0 is 1. We are not writing that one. And then we are having here c3 and we multiply by x. Now next is 1 and 1. So we are having c4, we are having here the value of c4 e to power x and 1 is 1, plus we are having c5. Now root is repeated, we multiply by x e to power x. Whenever the root is repeated, we multiply by x. Now become the complex roots. Alpha is 3, beta is 2. So we get here e to power alpha x, e to power 3x, beta is 2. So we have c4, now we have c5, c6, cosine 2x plus c7 sine 2x. Now we write the next one. Again, this is being repeated. So when it is repeated, we multiply by x. When we have e to power 3x, so we get here c8 cosine 2x plus c9 sine 2x. They all are linearly independent. Why they are linearly independent? Because when we are having the repeated roots, we multiply by x. Here we multiply by x. Here multiply again x, become x squared. Not repeat here e to power x, and then repeating here multiply by x. And then we are having here one root is missing, that's e to power minus x. So we can write here the root as x here plus c10 e to power minus x. So that's the distinction root. This is not repeating, this is repeating, this is repeating, and this is repeating. The complex root which is repeating. So we get here e to power 3x is my real part. Imaginary part is 2, alpha is 3, beta is 2. So get c6 cosine 2x plus c7 sine 2x. Then we are having again the same, is repeating. So we multiply by x and we write alpha is 3, beta is 2. Now here this was the distinction root, but not any in any other group. So we get here c10, and we write here e to power minus x. This is how we can write the solution when the roots are given. You are given the 10 roots, and we use that one to write our general solution. So as I always say that we are having some examples on the board. It's not possible to take many examples because of the time, but I'm always putting my notes in the description, the link in the description. You can just copy my notes from there, the soft copy of that one. Then we are making the videos, as this is part 3. I would like that you get the videos of my lectures, and you can get it if you subscribe our channel, like it, subscribe it, and click the bell icon so that you get the notification for the videos and you can learn it and enjoy it. I hope so you are enjoying with me. I'm always teaching the things in a very easy way, and try to take my students such that they may be able to understand that one. So this next is our example 8 is a different example. Now before we are having given the differential equation and we are finding the solutions. Now we given a solution in the form this particular solution is given, and we want to write the differential equation for that one. That's not at all easy, difficult, it's very easy. So I will tell you, just we will find the roots. And finding the roots, we just then multiply the roots and then replace our m by y dash m square by y double dash m cube by y triple dash, and we'll get the differential equation. Let us see how it is working. So we are having here the solution is in a particular solution, we write here y equal to 1 plus 5x plus 2 cosine x plus 3 sine x, a particular solution. We write the general solution. We get here y equal to c1 plus c2x plus we're having c3 cosine x plus c4 sine x. Now we can get the idea that these roots are repeated, and the roots, as we have seen it before, that is, the roots are 0, 0, because when 0, 0, then c1 plus c2x. So it means the roots here is m is equal to 0 and m equal to 0. Now in this case, our alpha is 0 and our beta is 1. The coefficient of cosine is cosine 2x, not the coefficient, the angle. Then 2 is our beta. Then it's here 3, then 3 is beta, 4 is beta, here is 1. So beta is 1. Now here e to power alpha x, now when this is the value of alpha is 0, then this is equal to 1. So we say we get here alpha equal to 0 and beta is equal to 1. So we having the roots of this one. This is here my m1, this is my m2, this is my m3 and the m4. These are my roots. So I simply write this one. This is my m square is equal to 0 and here my m square is equal to 1. It's equal to minus 1, because when we are having here minus 1, then we get here iota square. So when we multiply these two, so we get here m square into, and here we can write here m plus 1 equal to 0. So we get here m square plus 1 equal to 0. That give me here m to power 4 plus m square equal to 0. So what we did, we just make a replacement. We replace m square by m double dash. So we get here d4 y by dx4 and plus d2y by dx square, and this equal to 0 is my differential equation. So I hope you don't find it difficult. We just gone opposite. This was particular solution because we're having the values, not the constants. And from this particular solution, we wrote the general solution. And from the general solution, we're able to write our roots. And from the roots, we can write our m's. And we're having m square equal to 0, m square equal to minus 1, m square plus 1 equal to 0. Multiply them because these go upward. Differential equation, characteristic equation, factorization, and then writing the roots. These are the roots, and this is my general solution, and this is my particular. So we got opposite way to this side. So we are going to give another example. We take another example. We want to determine a linear differential equation having the solution e to power minus 2x, e to power 2x, 2 sine 3x, 4 cosine 3x. So we write the particular solution as we did it here. So y is equal to c1, y is equal to c1 is 1, e to power minus 2x plus e to power 2x plus 2 sine 3x plus 4 cosine 3x. This is my particular solution. Whereas the general solution, I write here this general solution for the same one. We get here y equal to c1 e to power minus 2x plus c2 e to power 2x plus c3 sine 3x, c4 cosine 3x. Now we are in position to find our roots. We can find the roots. Our roots are here. This here is m is equal to minus 2. Here m is equal to 2. Here alpha is equal to 0 and beta is equal to 3. So I can write my roots here. This is here is m minus 1, m minus 2 is equal to 0, and here get here m plus 2 is equal to 0, m minus 2 is equal to 0, and here we can write our m square is equal to 9. So we're having 3 square, that's equal to 9. When we take here minus 9, because when we take the root, we get here the complex root. So that give me m square plus 9 equal to 0. So I multiply them. I get here m plus 2. We're having m minus 2. We get here m square plus 9 equal to 0. Now we multiply them together. We get here, to simplify this, we get here m square minus 4 into m square plus 9 equal to 0. Multiply them. We get here m to power 4 plus 5 m to power 2 and minus 36. So that's my solution in the characteristic equation form. I have the characteristic equation form. Now we can write my differential equation. So my differential equation will be equal to, in this case, that's my solution, d4y over dx4, x is our independent variable, plus 5 d2y by dx square plus 9 into 36, we get here minus sign, minus 36, y is equal to 0. This is my differential equation. Again, we have the same. This is my particular solution and this is my general solution. These are my roots and this is my characteristic equation. And then I can write my differential equation replacing m square by the second derivative, m4 by fourth derivative. And want to solve the differential equation, we go from bottom to up and we get the differential equation.